Hello everyone, welcome to our channel. Myself Vikas from Sri Venkateswara College of Engineering, CSC department. In our topic, basic shift and register with processing scheduling and queue implementation. Our team members are Venkatesh Goda and Sahil handling on the mini project. Introduction. This discussion contained digital design and computer organization, operating system and data structure algorithm to explain a basic shift register process scheduling and queue implementation. Shift registers. A shift register is a sequentially circled used to store and manipulate binary data. It works shifting the bits, strokes, flip-flop in each clock cycle. Key points are purpose, temporary storage, series to parallel conversion, and data transfer type. Serial in, serial out, serial in, serial out, parallel in, serial out, parallel in, parallel out. Shift registers are visual for understanding hardware level data management in DDCO. Process scheduling. Process scheduling, the operating system determines how processing program in execution are assigned CPU time, its realize and queue mechanism, and it essential for resource optimization. Key scheduling algorithm. FCF, first come first service. Simple queue based scheduling. Round robin used circle queue to time slicing. Priority scheduling, process are queue based on priority. Like liking to DDCO, shift registers can model how to process are shifted for scheduling, stimulate the time slicing. Queue implementation on DSA. A queue is line data structure, linear data structure in which elements flow first in first out. Principal type queues are types of queues: simple queue, basic FIFO queue, circular queue, priority queue, and queues are circle for implementation process scheduling algorithm. And the circular queue, avoiding a space wastage by connecting ends. Priority queues, elements dequeued based on priority. Understanding queues structure is essential for implementation scheduling algorithm and optimizing performance. And the applications are task scheduling, a real-time system. Shift registers can be used manage the status of the task in real-time system. Process scheduling algorithms like round robin used shift register to efficiently queue and track, ensure smooth task execute with a time queue. Data flow management in pipeline. In the multi-stage processing pipelines, shift registers are used to hold or transfer data between stages while processing the scheduling, handling, execution of tasks in ordered manner. This is circular for the optimizing throughput and minimizing the pipeline stalls. Resource allocation in the operating system. Operating system use shift registers in combination with the scheduling queues to allocate CPU time processing and shift registers tag task and stage to each process, while the scheduling ensure the fail efficiently resource distribution based on algorithms like FIFO or round robin. And the benefits are efficient task and execution. Shift registers allow process to be efficiently queue and execute in sequence, make it essential to manage and process tasks in ordered manner. Priority in order robin scheduling. Simplify the process taking. Use a shift registers help to keep a track process status. Value making it essential to monitor and output process program with a queue. Optimizing resource management. The combination of the shift registers with the process scheduling ensure the better essential allocation by managing the execution ordered, maintaining a balanced working access task. Improve the time management. Implementation shift registers with a time queue based scheduling like round robin allocation for the fair process execution. Preventing tracking over ensure that each task gets a fair shared and CPU time. Benefits: efficient task execution. Shift registers allow processing to efficiently queue and execute in sequence, make it easy to manage and process tasks in ordered manner, particularly in round robin scheduling. Simplified process tasking. Use a shift register help to keep a track process status. By shifting the value, make it easy to monitor and update the process programming with a queue. Optimizing resource management. The combination of the shift registers with a process scheduling ensures the better resource allocation by managing the execution ordered and maintained a balanced work across the task. Improve time management. Implementation shift registers with a time queue based schedulings like round robin allocation for fair process execution prevent the stagnation and ensure each task get a fair share of PCU time.
So hi guys, myself Venkatesh Gowda and so I shall be explaining about the coding part. So what does this program do? This C program combines the simulation of a round-robin CPU scheduling algorithm with a shift register mechanism to track the execution status of processes in a systematic and illustrative manner. The program defines the two memory components such as the shift register and the round-robin scheduler. So what does the shift register do? The shift register is implemented as a fixed array size called as shift register size. It is initialized with the zeros representing a hardware-like register that visually tracks the processor states. Using the shift function, the register performs the left shift and appends a new value such as 1 for execution and 0 for the completion, helping to visualize the ongoing operations. On the other hand, the round-robin scheduler is implemented using a quick queue-based structure where process is defined by the process structure and represented by the process ID such as PID and a burst time process ID such as burst time. The scheduler itself is managed for the functions like initialization such as init scheduler and process addition such as enqueue and process removal such as dequeue. The core of the program lies in the execute scheduler function, which dequeues the process one by one and simulates their execution for a fixed time quantum. If a process burst time exceeds the quantum, it is requeued with its reduced burst time. Otherwise, it is marked as incomplete are also marked as complete. During each execution cycle, the shift register updates to reflect the status of the processes, making the operation sequence visually traceable. The main function is declared over here. So you can see the main function which has in which we are using the methods such as init shift register and init scheduler. So what does those function do? During each execution cycle, the shift register updates the reflect the status of the processes, making the operation sequence visuable and traceable. The main function initializes both the scheduler and shift register, adds a predefined set of processes with varying the burst time, and executes the scheduler with a fixed time quantum. The program prints the contents of the shift register and detailed logs of each process execution, allowing the user to observe how the processes are scheduled and completed over the time. This implementation is an excellent demonstration of round-robin scheduling and basic shift register operations, blending the theoretical concepts and practical coding. So we can see the output over here in which all the execution processes are listed over here. So we can see the shift registers such as 000, 001, 0011, 0111, 1111, 1110 and 1100. So we can also see the executing process also being completed each by each, in which the in which the register are executed in a priority wise, and we can also see that the remaining burst time is also displayed over here.
The system ensures smooth execution of processes with efficient management on their burst times. The use of a shift register tracks the progress of each process, indicating execution of completion, which helps avoid delays or system bottlenecks. Fair CPU time distribution. By combining a shift register with a round-robin process scheduling algorithm, each process receives a fair amount of CPU time, which minimizes the risk of starvation and ensures all tasks are handled in a timely manner. Improved system throughput. With the ability to manage and queue multiple processes, the system increases overall throughput by keeping the CPU busy, reducing idle time and maintaining a continuous cycle of execution, which enhance overall system performance. Next we can see the conclusion part. The integration of basic shift registers with process scheduling and queue implementation presents a powerful combination of concepts from operating system and data structures and discrete design and control optimization. The use of the shift registers allows for efficient tracking and management of process states, ensuring smooth execution and scannerization in the context of operating system. It supports process scheduling algorithms like round robin, which guarantee fair CPU time distribution, thereby preventing starvation and improving process throughput. From a data structure perspective, the queue implementation enables effective management of tasks, ensuring that processes are handled in an orderly manner. Finally, applying DDCO principles optimizes the overall performance by ensuring resource utilization is balanced and efficient. This multidisciplinary approach enhances system efficiency, throughput, and fairness in process execution, making it an essential concept in modern computing systems. Thank you for watching this video.